Hello and welcome to the Rubber Duck Dev Show. It is September 29th, 2021. It's almost time for Halloween. Getting close. Are you going to wear a costume on Halloween show?
Had not thought about it.
All right, chat, should we? If we do, what should we be? All right, let us know. Okay, so tonight
We'll dress up like rubber ducks.
There you go. I mean, it would be appropriate, I suppose. Anyway, my name's Chris.
I'm Creston.
And we are going to talk tonight about UUIDs. To UUID or not to UUID? That is the question. Whether it is nobler in the mind to suffer the bits and... Oh, never mind.
And bites.
So, before we get into the UUID stuff, what'd you do this week?
So did a bunch of stuff, but first thing I wanted to mention, because we always do these shows, and the last show was on background job processing, and I always remember stuff to mention after the show. One thing I wanted to mention, it was an interesting library for Ruby called Shoryuken, or Shoryuken, I can't remember.
Sure you can.
Yeah, exactly. And apparently it comes from Street Fighter, I think, because that's what one of the moves says or something. But basically, it's a library that does job processing, but it uses the Amazon's SQS service to do it. So it's basically, you get this library, you put it in your Ruby app or Rails app, and you can use the Amazon SQS service as a queuing solution to process jobs. So that's just another option I wanted to mention.
Cool.
Other stuff I worked on, talked about APIs that we did a couple weeks ago. I did some updates to my graph API for my app, adding some more queries for users to be able to grab different data that they're looking for. In terms of client work, continuing to work on some Rails upgrades, because like I said, whenever you're upgrading Rails, those gems can be a little bit of a nuisance. Address some bug fixes for some clients at their request. Talked through some AWS deployments, so assisting them moving their app into AWS and some best practices around that. And the last thing is basically just doing some Postgres consulting with some query optimization and maybe discussions around adjusting the schema to get the best performance for some of the apps that they're working on. So what'd you do?
Let's see.
Stuff and things.
Stuff and things and things and stuff. No, we had some more conversation about the question of the week last week at work. We're still kind of having that debate. I mean, it's not a practical issue anymore because we've settled the actual programming change we were working on, but we're still kind of having the philosophical debate of should background processes spawn other background processes, or is that dangerous? Are there certain situations where it's okay? Is it never okay? Should that just not be allowed? So we're having a lot of discussion about that still. But at this point, it's more of a philosophical musing on downtime chats. But
now, what's wrong with just having, like, if this is going to spawn a job's going to spawn multiple jobs, presumably there's additional work that needs to be done. Why not just make this like a long running job that just addresses everything it needs to do?
Well, because of retries. If your job is doing things that, if it's reading stuff out of the database, and that stuff could have changed in between retries,
yeah,
then it may not be a good thing to do. Because, like, let's say, for example, I want to send a receipt out, right? Well, if that order can change in between retries, I don't want, I want that receipt to go as it was the first time I sent it if it's doing retries, right? I don't want it to change in between. So in that case, what you would need to do is kind of have a job to gather the order and prepare the receipt, and have that spawn a job that just gets the receipt as a parameter and emails the receipt. And that job, that sub job, is the thing that retries and retries and retries so that it doesn't change in the meantime. So that's kind of a use case where sub jobs could be a thing that you'd want to do. The problem comes in when you have to try to troubleshoot and track those things down, and you end up with multiple layers of this job spawns this one that spawns these two others, that each one of those spawns 4 jobs, and oh my god, where did this one come from? So it becomes a troubleshooting nightmare more than a mechanical nightmare. So there's still kind of...
and I suppose if you have a long-running job that has particular work and you don't want to start over from square one, like if you're able to commit certain changes through the process, you don't want to have that all part of one job and then something fails and then it retries the job and it's like, no, I was 75% done, for example.
Well, and that's the other part of the consideration is when you have thousands or tens of thousands of these jobs going, you want to have the repeatable jobs as small as they can possibly be. And you want the long-running jobs to run as few times as is necessary. So, because I don't want, sending an email 10,000 times is a lot better than reading the database, creating an order, doing all the calculations, and then sending the email 10,000 times. So, there's a queuing issue that goes on there too. You want to make sure those jobs can get disposed really quickly if you're, doing lots of transactional things. So, there's use cases, but I think the real crux of the philosophical debate is it maintainable, and is the troubleshooting a nightmare if you start chaining these things together?
Well, I would think if you have something that, say, creates an order, a job that creates an order, and then a receipt needs to be sent, I wouldn't see any problem with spawning a new job that would just get put in the top of the queue or bottom of however you want to phrase it, to send that email. So it'll eventually get sent. Meanwhile, you have your first job that creates the order. That instance of a job spawning a job makes perfect sense. But then if you start going down the rabbit hole of more, then...
And kind of the part of the discussion is, okay, at what point is it too much?
Yeah.
What's the protocol? Do I say, hey, you can have a job spawn one other job and that's it? Or can it spawn 2 levels? Or, when do you cut it off and say, all right, no, that's... And I think the conclusion that's kind of coming out is, by default, don't spawn sub jobs. But if you have a use case where that's really the most appropriate thing to do, let's take a look at it, from a team perspective, get all the input and say, yeah, we think this is safe, and yeah, this is not going too far. And really that's kind of the best way to approach a lot of protocols, I think. But you kind of have to be careful with that from a management perspective and from a creativity perspective and all the things that go into
having everybody on the same page.
Yeah. So, but anyway, and then, I've done all the programming and stuff, a lot of which I can't actually talk about, but that's,
yeah,
it's, a lot of fixes for little things. It's been a lot of bug stomping this week. So, just 800 little 1,000 tiny projects that have to be done. It's just one of those weeks. But all right, so on to UUIDs. First, I want to pose the question of the week to the audience. If you are joining us live, feel free to pop something in the chat. If you're viewing this afterwards, feel free to put something in the comments. We will read them. Do you prefer to use UUIDs or integers for primary keys on your objects? That's the question of the week. So, I've been doing this a long time, and I've been using,
and by this you mean
programming development.
Yep.
Right. And my entire career, UUIDs and GUIDs have been around. I mean, they've been around for a long time. But I never really stopped to think about what they actually are and what they actually mean. I mean, I knew when to use them. I knew what the concepts were, but when we were prepping for this show, one of the things we were asking is, why all the hyphen sprinkles? What's that all about? What does this mean? You know, we've been seeing them for 20 years, but what are they? So
that's one reason I really don't like them, because like, so why they have all these stupid hyphens? I don't know. Anyway,
yeah, because I can never just type one out and say, oh, I need this and this and this and this and this. There's a UUID. Yeah. No, it's okay. Let's get my language to generate me one, and I'll just copy it. So let's start with just, basic definitions. What is a UUID and what is a GUID? So the first thing is, basically, those are interchangeable in most development conversations. They're just used interchangeably. There are technically differences. GUID is the Microsoft implementation of UUID. And there are some subtle differences, like GUIDs have to have uppercase letters when they're, because it's hexadecimal, so you have A through F. Those have to be uppercase in GUIDs. Microsoft tends, I mean, if you look into the registry on a Windows system, you see GUIDs all over the place. Microsoft uses them to identify their, specific releases of their different products and all that kind of stuff. And that's how MSI works and all that, how the registry registers programs and stuff like that. So
the registry's littered with,
oh God, it's just like 90% of registry entries are GUIDs. But so in general, those things are used interchangeably in development environments, in conversations. So what actually are they then? Why the hyphen sprinkles? What's that all about? So basically, they are 128-bit hexadecimal identifiers, and they're used to uniquely identify an object, in theory, universally. Like this UUID will only ever belong to this thing, and this UUID will never be used by any other thing in the universe ever again. Now, we'll talk a little bit about the realities of that, but okay, so that's essentially what they are. The sprinkles, the hyphens are basically there to separate the fields of the bits that are making up the entire UUID. So each field is basically an unsigned integer, and what you've got is a 32-bit block, a 16-bit block, a 16-bit block, 8-bit, 8-bit, and 48-bit. So if you look at it, it looks something like this. Now, UUIDs are defined in RFC 4122.
Are you able to zoom that in a little bit, or not really?
Am I able to? Of course I'm able to.
Yay.
So you've got this first block, and then you've got these two blocks, and then these three blocks, and then a final block. So that's kind of the layout of the pieces of a UUID. And they're generally made from something like pieces of timestamps and MAC addresses and or hardware IDs or random node IDs, depending on which version you're using, to try to guarantee that it's always going to be unique. So there are actually 5 versions of UUID, and along with some variants of some of the versions. Version 1 is what we use most today, and that can either be the last block is either a MAC address or a hash of a MAC address, or it's just a random or pseudo-random node ID.
Now, actually, I thought version 4 was the one that's used most commonly today because it's pretty random.
Well, version
and
4,
not version 1.
Yeah, it's actually not used as much, although I think it should be, because it doesn't use timestamps. It doesn't use.
I mean, it's more computationally intensive.
It is. And that's one of the reasons that it's not used as much in some circumstances, is because it's all random or pseudo-random. And so they actually take a little longer to generate. And technically, there's more of a chance of collision with that than with the other ones. Though
more of a chance of collision with version 1.
There's more of a chance of collision with version 4 than there is with version 1, actually. Now, those chances are so small as to be almost infinite, so it's not really a concern. But the big reason why version 4 is used a lot, but version 1, especially in fast things, is implemented more because it's faster to generate.
Like, it looks like, I was just doing some searching. It looks like Google, I'm sorry, what am I saying? Google. Looks like Postgres, at least its function, returns a version 4.
Right. Well, and most UUID generators will implement most of the versions. They'll implement more than one version. Except for version 2, because version 2 is defined as version 1 with DCE security, but that's never actually defined anywhere. So most UUIDs don't implement version 2. But the long and short of it is version 4 is pretty much completely random, and so it's safe. And one of the reasons version 4 came about is because version 1 with the MAC address actually led to a pretty nasty virus that got released that used those MAC addresses to start identifying things. So version 1 became a pretty significant security problem. One of the reasons they have a variant for version 1 is because they replaced the MAC address with a random node ID. So you still get the timestamp stuff blocks, but where the MAC address was at the end is just a random number. So to try to eliminate the security issue. So, and then there's 3 and 5 are name-based, and then they use MD5 or SHA1 hashing algorithms to hash the namespaces that they're pulling from and stuff like that. But they all have the same structure. So a UUID, just by looking at the UUID, you can't really tell what version it is often. I mean, if you just look at the string, because they all look pretty much the same. Except I think version 4 is like a couple less bits. I think it's 124 bits instead of 128 or something like that.
I thought it was all 128.
Well, I thought so too, but when I was looking into it, I think they were saying version 4 is actually like 124 bits instead of 128. Read that somewhere. But anyway, there's lots of versions. There's lots of ways that these things are generated. But in practice, each one that's generated is unique. Now, there are, if you were to do, I think I was reading, I can't remember if it's version 1 I was reading this for or version 4, but there's something like 1 in 5 quintillion times you may get a collision So that's essentially never.
Yeah.
And version 1 can't be guaranteed to be unique because MAC addresses can't be guaranteed to be unique because they can actually be changed. So you could get collisions there potentially, but the chances of that are so small as to really be impossible almost. So you don't generally need to worry about, is this going to actually be unique across everywhere? Probably yes. So one of the interesting things that I found this week as I was prepping for the show is I started to look at, where did UUIDs come from? What's kind of the history of them? What are they there for? They haven't actually been around as long as I thought they were. They were actually not really a thing until the 1980s with Apollo computers. And the first thing they did was they implemented something called a UUID, which was just a 64-bit identifier. And it was only for internal identifications on their NCS or network computing system to ID entities internally. 64 bits was plenty for them. But then they were trying to work with industry to standardize, and they wanted to get everybody to standardize around that spec, and 64-bit wasn't enough, so they came up with the 128-bit UUID, which wasn't quite the RFC 4122 version 1 spec yet, but it was basically there. So it really was the UUIDs came out of an internal thing from Apollo computers, and then it was created to standardize the rest of the people in the industry around this so that they could interact better. And I just thought it was interesting that I assumed that something like a UUID, whether it was called that or not, had existed since the first computers, but it really hadn't until we got to networking. It seems that it wasn't really a necessity.
Yeah, that makes sense. I'm seeing something about UUIDs in version 4, and that the bits are used for the version number.
Okay.
So
yeah, it's still 128 bits, but only 124 of them are used for the identification part.
But anyway.
It was, yeah. It's little weird things. And there are, we do have some links
when in doubt, use your programming languages
right
library.
You usually don't have to know this stuff. Yes. Like I said, I've gone 20 years without knowing a lot of this stuff because it's just not necessary to program. You tell your programming language, hey, give me a UUID, and it does. You know.
Yeah, like in Ruby, you just say something like you require secure random, and then say,
right.
dot UUID, and it gives it to you.
Or you say, hey, Postgres, I'm defining this as a UUID field. Go.
And it just, and or a function says, give me a UUID. It gives it to you.
Right. So you generally don't even have to worry about what do the hashes mean? How is this built? Is it really universally unique? All that stuff. The other interesting thing is, while it says universally unique identifier, which means I get this thing and nothing else will ever have it in the universe ever, that's not technically true. It's practically true, but technically it's not. It is possible to get duplicate UUIDs for a couple of reasons that we've gone over. MAC addresses aren't necessarily global unique, and that in version 1, in one of the variants of version 1, MAC addresses were used. The timestamps can actually be repeated, and since timestamp was a big part of the UUID, you can get collisions because timestamps that because of clock drift and or random chance, you can get duplications there. And some versions of variants that are using RNGs or pseudo RNGs could get duplicates, especially if they're on different machines. So all this stuff could happen. The simple fact of the matter is, in practical terms, you're talking about such a small likelihood of that occurrence that it's not something that I've had to worry about in 20 years of doing this. I've never run into it. I've never known anybody that's run into it. I've never even read about it happening. But statistically, mathematically, it can. Which, again, yes, that's interesting. But it's not really practically an issue. So, yay. All right. So, speaking of practical stuff, that's all the philosophical mumbo jumbo history goo that I like. But let's talk about why would I actually use these? So, why would you actually use these? Besides Microsoft using them to identify their programs, where would a programmer use these?
Are you asking me?
Yeah, your turn to talk.
So I mean, a lot of people like using them for their primary keys.
Well,
And
why?
I'm sorry, go ahead.
Why?
I don't know, because I don't. And now where they shine, in my opinion, is if you have a distributed system and you're generating IDs from outside of the database. So if you're generating some sort of identifier on clients, or heaven forbid you have a, oh my gosh, I thought of the term. I was going to say multi-tenant architecture. The microservices that are all talking have their own databases, and you need some sort of unique identifier between them. Having a UUID could be a way to do that, to pass, this information across to each other uniquely. But that's the way I tend to use them. The only place I'm using them, for example, in my application is when I have someone new coming to the site, I generate a UUID for them, or for a JavaScript client. I have the JavaScript client generate a UUID for it.
Mm-hmm.
So as opposed to something in the database. So that's something they can just send off without having any back and forth communication. They can basically send it async to my database and it'll receive it and store it, and doesn't need to send back, hey, here's what your unique identifier is.
Mm-hmm.
Because generally the JavaScript, you can do that and store it in a cookie. And then now that is that JavaScript's application's identifier from then on. So it's basically a client generated identifier.
Right. Now, why would you not want to use UUID as your primary key?
So I think so I guess one big reason, I think there's multiple reasons. One big reason is that it can hurt performance in terms of databases, because generally you're going to have an index on this UUID to identify them. Now, the problem that happens is that when you imagine you have a sequence and an auto incrementing integer, it can easily put that at the end of the index page, any new inserts. Whereas when you're talking to UUID, it's got to search and find the exact place to put it. Now you're having random IO across the index, and you may have to do a page split because they are particularly large compared to an integer to be able to put in the right place. So you can actually get much more throughput on inserts when integers are your keys compared to UUIDs.
Right.
And this also results in bloat, at least in Postgres, bloat they bloat more and also impact your transactional performance. So much so that there have been suggestions from different from different places that if you're going to use a UUID, you may want to consider using a pseudo random one. So basically, it is like the first half of it is more ordered, and then the last half of it is random. And that enables at least to minimize some of these bloat issues and performance issues with doing inserts of these new UUIDs.
Right. But if you do that, then you have to be careful about assuming that's going to be universally unique, because you're actually taking control of part of the randomness of it.
But if you're doing that pseudo random, presumably it's being generated by the database and not some other place. Anyway, that's a downside of them.
Yeah.
The other downside, they are large and having to store more information. And I mean, frankly, I just find them harder to work with. Like when I'm working with a database that uses UUIDs, it's just this gosh awful big thing there. It's like, oh my gosh. And like, imagine like in my app working with my database, I say, okay, find me, I'm looking at some, oh, find me ID. And even if it's 6 digits, 1, 2, 3, 4, 5, 6 or whatever in the console to be able to find something. Now I got to type this enormously long, I got to copy and paste it. And, it's easy to find out, oh, wait, that ID is not this ID. So just working with it from a programmer's perspective, debugging something, they're a lot harder to work with just because they're,
that's
so
the biggest
larger.
problem I always had with them was the troubleshooting angle.
Yeah.
If I have to say, hey, what's this ID? That's 32. Great. I can remember that. I can look it up in several logs and stuff, and I can remember 32. Hey, what's this ID? 4A6F3-DC. Stop. I'm done. Paste it in an email and send it to me.
And then the other issue is lack of easy ordering, because so many times some solutions to problems, if you have a sequence and it's an ID, you have high confidence. It's not going to be 100% of the time due to probably timing differences. But if one integer is larger than another, it happened after it.
Right. If I've got a million things in a database and I see ID 2, I know that's an old record.
Right. And it's easy to order by and get the first one or the last one, so it's just, again, makes it easier to work with.
Mm-hmm. Now, of course, all of these things can be done with other things. And like in the Rails world, you always have, well, by default, a created at and an updated at, so you can order by that. But again, it's faster to order by integers. Integer indexing is, I think, the fastest indexing. Well, maybe Booleans or bit indexing, but even then,
but Booleans, again, that's just true false, and that's low cardinality. So
right. So
if you're talking a B-tree index, I would think it would be, small integers.
Right.
But that means, like, now if your UUID is the primary key, okay, but so you're talking about much larger indexes. So now your primary key is much larger. And then if you need to do that ordering like we were talking about, now you need to add an additional index onto your created at or your updated at, which you may not have to if you were using incremental IDs.
Right. Now,
incremental integers.
If your table might get up to 1,000 records, these speed considerations are not really a consideration.
Yeah.
But if you're doing things where you've got 1 million records in a table, it's a big difference.
Yeah. And think billion, because I've worked with clients that have multi-billion rows in tables. And there it really makes a difference.
Right. Of course, the other problem you have is with most integers, most primary key integers, you do have a limitation on how big an individual integer can be. So it will at some point flip over where you don't have that problem with UUIDs.
Yeah. And that's important to, call this a public service advisory or whatever, but use big ints if you suspect your app is going to do anything, or even just do it anyway. Use big ints for your primary keys.
Yeah, because the space difference is negligible, and
at this point it's negligible.
Yeah. I mean, in the days of COBOL, that was a big difference, but today, use a big int.
And Rails does that. For example, Rails, does that. They didn't used to do that, so that's, well, that may have been like version 4, but in some version in the last, I don't know how many, handful of them, they started using big ints for the primary keys.
Mm-hmm. Which only makes sense. And I think big ints will go to what, like 2.14 billion or something like that before it.
No, that's an integer. Goes
that's regular int. Yeah. So the big ints are orders of magnitude higher than that.
Yeah.
So, and honestly, I always thought, look, if I get into a situation where I create something and it has more than 2 billion records in a table, an individual table, I'm probably retired and not caring anymore at that point. So,
or you're the programmer that was hired onto the team, and now it's hitting the limit. Now you got to deal with it.
Yeah, but at that point, it's time for me to retire and not care about it anymore.
I know, but I'm saying you're not the guy that created it. Right. You're the programmer that's been brought onto the job to fix it because you weren't there at the start.
Which, happens in a gig economy. So
now the other thing to mention is that one advantage that people assign to UUIDs is that it helps with security, although that I've heard it, but it's a little bit, but I'm saying I'm dubious about it as well, because I kind of think it's like a security through obscurity, because they don't want to publicly show what IDs are. Like when you go to a particular web page and it says, hey, you're on account 4 or you're on order 2042.
But so what? My rebuttal to that would be, yeah, there was specifically a virus created that used UUIDs as the hole to get in. So security, I've never heard of that with an integer,
Well, yeah, it's security through obscurity.
So,
and they can learn, but if you're that worried about certain visibility into your app for it, you could always create one if you wanted for that use case, but
yeah,
doesn't necessarily have to be your primary key.
But honestly, I think if you're doing security through obscurity, you need to reevaluate your plan for whatever you're programming, because that's usually an indication that you've got bad security. That's not a good security scheme. So if that's your reason for using UUIDs, you might want to reevaluate your reasoning.
Yeah, I mean, I wouldn't think that would be a valid reason to do it.
No.
Personally. I mean, I would probably actually, if I wanted to do it, I wanted to put some obscurity, and I probably wouldn't use a UUID because it's just too bloody long. If I wanted some sort of identifier to hide what my integer primary key is, I'd probably come up with a 6 to 8 character or 12 character, something like that, and just have a unique index and have it along with the internal ID and have a unique index on it that it'll regenerate it or something if it, happens to hit a duplicate.
Right. And I have actually done that before. We had worked on a system where we had to give users like a 9-digit code that would be unique. So they never saw the primary key ID. What they saw and what it was looked up by was this 9-digit code. So, and that, generated, and if it was replicated, but it didn't need to be universally unique. It only needed to be table unique.
Mhm.
So, you know, that's easier to control. So, you know, there are use cases, valid, legitimate use cases for UUIDs. I don't think there are as many as a lot of people apply them to. I think they're applied a lot of times when they probably shouldn't be, or there's no real reason to do it except that all the cool kids are doing it. So, you know, that's
Yeah. Oh, and there's one more thing I forgot about is that whatever you do, if you're going to use them, use the data type for your database to store them.
God,
Do
yes.
not use text because otherwise it's going to be even larger.
Yeah. Oh God, no. That's
So there should be, like Postgres has it, there should be a UUID data type in your database. If you're going to be storing them, use that. Don't just use a text field.
and if you need to use a UUID and your database doesn't have a UUID type, get a different database. Because why? Why would it not? I mean, they haven't been around forever, but they've been around long enough. What, 40 years now? Plenty of time databases. Come on. I don't think I've ever run into a database that doesn't have a type for that. Not.
Yeah. Well, I mean, just make sure you're using them.
Yeah.
So it'll try to minimize somewhat some of the disadvantages we talked about.
All right. So, any final thoughts on UUID or not to UUID? That was the question.
Yeah, I don't think so. I mean, for me, the reason to do it is if you need to generate an ID outside of your primary database, like your client generates it and you want the client to say keep it in a cookie like a JavaScript app or even a mobile app. If you want someone to sign up to a mobile app and you want, for whatever reason, the client to generate the unique identifier for that person and then send it to you that you store, then that makes sense to use UUIDs. Otherwise, with the performance disadvantages that you can see, I wouldn't use them most of the time, but that's my opinion.
Right. And my thoughts are, don't always use UUIDs for primary keys. There are use cases where you should, but those, in most cases, should be the exception. Those should be tables that have a specific reason for having a UUID. Don't just do it because, hey, UUIDs. It's not better. It's better for certain use cases. So there are trade-offs. If you decide to do that, you're making some trade-offs. And you need to evaluate those to make sure that it's worth it. And in a lot of cases, it's not. So, all right. A little bit shorter episode, but that's all right. We crammed a lot of stuff in there. Don't forget about the question of the day. Do you like using UUIDs or IDs, integer IDs, for your tables? And whichever reason, why? Let us know in the comments below. Please do. We will read them. Also, join us every Wednesday night, 8 p.m. Eastern Time. We'll be just, talking about random programming stuff. Next week, should you comment your code? Have some controversial stuff going on there.
2 weeks of controversial topics.
I know, right? UUIDs, and then should you comment your code? We're just asking for a
revolt.
Yeah. Anyway, hope you guys enjoyed that. Don't forget to join us on rubberduckdevshow.com, where you can listen to the podcast version. Also, you can get the podcast version on most of your podcast providers. Any word from Apple yet?
I submitted to support. Oh, no. Yeah, no. I'm in the process.
Okay.
We'll
so
see.
iTunes should be coming soon, but the rest of them are covered. So if you're an iTunes person, just go to rubberduckdevshow.com and you can listen to it there until we can get Apple to do whatever it is they got to do.
Help us.
Yeah. So anyway, if you guys enjoyed that, please do mash that like button and throw some comments in there so we know you're listening. Also, what else? Oh yeah, subscribe. That would be cool. Or follow if you're seeing us on Twitch. We do broadcast this simulcast on Twitch.
And given how, social media companies tend to unsubscribe people and hide things from you, if you want to make sure you always get our episodes, you can sign up for an email newsletter. We just basically send you an email to say, hey, here's the link for this week's episode and what we're going to be talking about next week. So very simple email. You can just do that at rubberduckdevshow.com.
And if you have friends that you think would be interested in this content and they don't know about it, please pass the word along. That would help us a whole bunch. Share it on your social media and tell your friends. We assume you have some. I don't, but you probably do. Anyway, we will see you guys next week. And until then, happy programming.
Happy programming.